Now, for the second question, this is the second kind of flavor. So let's read the question first. A plane is traveling in the direction of 160 degrees with an airspeed of 400 miles per hour. Its course and ground speed are 145 degrees and 385 miles per hour respectively. What is the direction and speed of the wind? So for this one, it is different from the previous question because it actually gave you the ground speed and the course in the question. That means they gave you the resultant. So you need to find out the gap. You need to find out the individual vector. So let me go ahead and draw the picture first. Again, go ahead, draw a good picture. Draw a big picture. This is where it starts. And you're going 160 degrees for 400 miles per hour. Oh, no, hold on. That's not 160. 160 is over here. That's 160. That's 160 degrees. Okay, so label everything. 160 degrees, and that's 400 miles per hour. Yes. Well, north is 0. This is 180. So if you know this is 180, so 160 must be right here. And what is this angle right here between 160 and 180? 20, right? So you know that's 20. Might be useful. Might be useful. And then the actual ground speed is 145. So let me use a purple for the ground. Ground speed is 145 degrees and 385 miles per hour. So so something like this, I would say. All right, so this is 385 miles per hour. And this is 145 degrees. Now, just out of curiosity, what's the angle here? 15, right? Just out of curiosity. Is it useful? I don't know. Maybe. Who knows? Now, the purple line that I drew here is the resultant. So that means the two vectors added up together will give you this resultant. So that means the wind speed must be this one. It must connect the head to the resultant. So that's the wind speed. Okay, so we're wondering what's the wind speed and what's the direction here. Okay, so we need to figure it out. And we say this tiny angle is what? 15, right? 15 degrees. Let me go ahead and draw it out. This is 15 degrees. Okay, so can we find out the speed of the wind? Yeah, we have 3 sides and 3 sides and 1 angle, right? 3 sides and 1 angle. Law of cosine. So x squared is equal to 400 squared plus 385 squared minus 2 times 400 times 385 cosine of 15 degrees. Okay, so I'm going to let you find out what x is. If you put everything into your calculator correctly, you should get the wind speed at 103.537 miles per hour. Yes? Yes, okay. So that's easy. That's pretty easy. So 103.537 miles per hour. That's a wind speed. That's pretty gusty. But we then need to find out the direction. So we need to find out this direction. Well, how? And again, you look at this triangle. You have these 2 sides. You have the 15-degree angle. and you just find out the length of the other side. So yeah, you have all three sides. You have one angle right there. That means you can find out everything about this triangle. If you need to find out these two angles, what could you do? To find out the rest of the angles here, you can use the law of sines to find out the other two angles. So you could do that. You could find out this big angle. You could. But if you have that, how do you get theta then? Well, let me ask a question. What is this tiny angle right here? This is what? Not 15? What is this tiny little slice here? Maybe I use a different color. So to avoid confusion, let me use orange here. What is this tiny little slice? 20. Because? Yeah, so this is 20. So this is 20 degrees. So this is 20 degrees as well. Right? So alternate interior angles. Okay, so this is 20. That's also 20 degrees. So that means the thought process, yes. This is 160. So what's left? 20. Okay. So the thought process is that you are capable of finding this big angle right here. You are capable of finding this big angle right here. And after you find out this big angle, you will simply subtract or minus 20 to get your actual bearing. So so let's call this angle theta prime. All right, and say sine of theta prime over 385. It's equal to sine of 15 degrees over 103.537. So let's go ahead and find out what sine of theta prime is, and then find out what theta prime actually is. Okay, go ahead, take a moment. Use a calculator. Find out what sine prime theta is, and then what the actual theta is. Sine theta prime would be 0.962413, and theta prime, it's going to be 74.241 degrees. So that's the big angle of the triangle here. But since we only look for the bearing, so we'll do 74.241 degrees minus 20. So the actual wind direction would have a bearing of 54.241 degrees. Okay, so again, I don't want you to memorize how to find these angles because it's situational. Okay, whether it's adding or subtracting, it's based on the situation. So the key point here, okay, first, now if you look at these two questions together, I want to emphasize the key points. First, ground speed is your resultant. And in order to find the resultant, all the individual vectors must be connected head to tail. Okay. And you can always use law of cosines or law of sines to find out whatever you need. But the other main thing that you need to acknowledge is that with the law of sines and cosines, you can actually solve the triangle. You can find out all the angles and all the sides with the information given. And if you have those information, on paper, or if you know that you can find out those information, then you can find out the required information pretty easily. But make sure that you know how to label them. Make sure you know how to do the alternate interior angles. Okay, so that's probably one of the biggest struggle for students, because they may just stare at this part of the diagram and they don't know what to look at and they don't know how to find it, but it's from here. Okay, so so these are the main things for navigation. So make sure you know how to draw diagrams. Draw a big enough diagram not to confuse yourself. Questions about this question? All two questions together. Okay.